Okay, in this last video we're going to be looking at area and perimeter. Now, first thing is students often get confused between which is which. So I quite simply think of, if you have a shape, so let's imagine we have a rectangle, just a basic shape, put a couple of words together to try and link it in students' minds. So the words I put together are, imagine you have a play area and imagine you have some perimeter fencing. So if you had a play area, the area you could play on is this bit inside, which is full of squares. So that's our play area, full of squares. And the perimeter, I always think of perimeter fencing. And if this play area had perimeter fencing around, it would be here. And to check it, you would want to start here and walk all the way around until you checked all the perimeter fencing. So let's have a look at a question then. If we have this shape, and what you'll find is they're not drawn to scale, and they just have measurements written on. So let's start with a rectangle, and for all different 2D shapes they have different formulae for area. Rectangle, for the area, is base times height, or you might see that called length times width. Basically it's one side multiplied by the other. So we'll often have a measurement on, let's say we've got 3 centimetres and 7 centimetres. So the area here would be base of 7 centimetres multiplied by a height of 3 centimetres. And if you notice, I've written the centimetres on because one of the other mistakes students make is with the units at the end, and my units and the units of measurement. 7 3s are 21, but centimetre times centimetre makes centimetres squared, and that's important for area to get those units correct. It's units squared. And again, if we just go back to this analogy, the play area is full of lots of squares. If we then come on to a perimeter question, pick a different shape. Let's go with the triangle. So if we have a perimeter question, check the perimeter fencing, we're going to need to do it thoroughly, check all the fences. It doesn't matter where you start. Let's say this was a 10 centimetre by 8 centimetre by 9 centimetre triangle. If I was going to check all this perimeter fencing, let's say I start off this way, I'm going to end up with a perimeter of 10 centimetres first of all. Then I'm going to come down here, so I'm going to add 8 on. And I'm going to finish off going back to where I started, I have 9 centimetres on. 10 plus 8 is 18, plus 9 more is 27. It's just centimetres because it's just measurement in a linear, just a line. The only other thing to say on this that students sometimes make a mistake on is, let's say we use this first rectangle and now go back and find the perimeter. The biggest mistake I'll find students make on a question like this is, they will remember their areas inside the perimeter fencing, they see a 3 and a 7 and they will do 3 centimetres plus 7 centimetres. The problem is, that's only got me from here to here. It's then acknowledging all the other sides that potentially haven't got the information written on. If that's 3, that's 3, and if that bottom was 7, that was 7. So actually I needed to add on another 3 and another 7, and so that one for completeness got to is 20 centimetres.